Hey everybody, Math 104, welcome to section 5.4, General Approach to Factoring. I'm going to run through all the your turn problems right now. So first one, we've got matching binomials, so we can factor those out. Binomials can be factored out just like anything else. So I'm going to take the binomial, remove it, bring it out front. After we remove the x plus 4, what we have remaining is 3x minus 1. And we're going to subtract from that, remove the x plus 4 here, subtract x plus 2. Make sure you put it in parentheses because we need to subtract the entire binomial. And now it comes down to simplifying this. So when we subtract x plus 2, we subtract the x, we also subtract the 2. So both of those turn negative. Now simplifying inside, we have 3x minus x is 2x, negative 1 minus 2 is negative 3. So our final answer, final factored form, x plus 4 times 2x minus 3. For number 2, we have a 4-term polynomial. So always the first thing to think about there is factoring by grouping. 4 terms, factor by grouping. We're going to do these 2 at a time. Well, we can factor out of these 2. 16 is a common factor of both 16 and 32, so we can pull that out. And we have at least 2 x's in each of these, so we'll pull out 16x squared, giving us x plus 2. Now we want a matching binomial over here with x plus 2, so that means we need to factor out negative 9. And that produces x plus 2. All right, completing the factoring by grouping, I'm going to pull out the x plus 2. And that leaves 16x squared minus 9. So we're done with the factoring by grouping, but now we need to examine both of these and see if either of these are going to be factorable. Well, this is not factorable, but here we've got a perfect square in 16, perfect square in 9, perfect square in x squared. So we have difference of squares. Take the square root of the first term. That's 4x. Square root of the second term is 3. Don't forget to keep the x plus 2. And now using the difference of squares formula, we have 4x plus 3, 4x minus 3. And now that one is fully factored. Number 3. This one's very similar to what we had here. Perfect square, perfect square, perfect square. So that means we have difference of squares. So we get 4x and 7 for A and B. Plug that into the difference of squares formula. A plus B, A minus B, so we get 4x plus 7. And 4x minus 7. Number 4. Now we could go ahead and use the AC method, 4 times 96, and go on from there. That's going to be very difficult to do that way. So first step in all of these, always look for a greatest common factor. 4 divides evenly into 4, 20, and 96, so we can factor out 4. Now once we factor out the 4, now we have much easier to factor expressions inside the parentheses. So we're going to look for two numbers that multiply to get 24 and add to get -5. That'll be -8 and 3. Those two numbers go right inside the binomials. 4 times x minus 8 times x plus 3. So we've got a trinomial. It's going to be one of 3 types. It's going to be the ones like the one we just factored there, an a equals 1 trinomial. We've got some where the a is not 1, and a is the coefficient on the x term. So here we got an a of 9. So we could use the AC method. But if we look a little closer at this one, notice we have a perfect square here in 9, perfect square here in x squared, and a perfect square here in 4. So this could be a perfect square trinomial. So let's try that first. We'll find a by taking the square root of the first term. Square root of 9x squared is 3x. All right, take the square root of 9, you get 3. Square root of x squared, you get x. Square root of the last term. Find that to get 2. So there's our a and b values. Now let's see if it really is a perfect square trinomial. 2 times a times b should equal that middle term. So we have 2 times 3x times 2, and that is 12x. So that matches. This is indeed a perfect square trinomial. So we'll just take our a and b values, plug them in the formula, x, or 3x plus 2 squared. Number 6. Got 8x to the third minus 125. So this could be one of two things. Could be a difference of squares, could be a difference of cubes. So you got to figure out if these are perfect squares or perfect cubes. Well, 8 is a perfect cube. The big clue here is that x is to the third power. If it's a multiple of 3, that's going to be a perfect cube. 125 is also a perfect cube, so we have difference of cubes. Now make sure when you do these, you're taking the third root, not the square root. We want the third root to do anything with cubes. Sum of cubes, difference of cubes. Third root gives us 2x, and we're going to divide the exponent by 3, divided by the index. So 3 divided by 3 is 1, so we get x to the first power. B is the third root of 125, and that is 5. Now we can put that into the formula. So we have subtraction, so you know the first binomial is going to be subtraction, so that's 2x minus 5. Now within the second set of parentheses, we're going to have a trinomial. We'll start off with a squared, square both of these to get 4x squared. Now in the middle, we switch signs, go from negative to positive over here, always switch it. Now in the middle, we get a times b. It's not 2ab like a perfect square trinomial, it's just a times b. So 2x times 5 is 10x. And on the end, we'll have 5 squared plus 25. Number 7. So with this trinomial, we've got exponents that are bigger than 2. So that's a hint that we need to factor out a GCF first. All of these are divisible by 9, and we have x's in each term. Smallest exponent is a 1. So we want to factor out 9x. All right, now for the inside of the parentheses, we'll take each term divided by the GCF. So 18 divided by 9 is 2. X to the third divided by x is x squared. 9 divided by 9 is 1. X squared divided by x is x. 45 divided by 9, got negative 5 here. And the x's cancel. All right, now we can factor inside the parentheses, if possible. So we need to see if this is going to turn out to be factorable. So since we have something other than 1 here, we use the AC method. So AC equals 2 times negative 5, which is negative 10. Now we need two factors in negative 10. The multiply to get, or the add to get 1. Let's see if that's even possible. We add up all these. See, we got negative 9 here, negative 3, positive 3, and 9. All right, none of these add to get our middle coefficient. So this thing is prime. So that means there's your answer. That's fully factorable. Fully factored. Number 8. X to the fourth minus 25. So we have a difference here. We got a binomial, so it's either going to be difference of cubes or difference of squares. 4 is not a multiple of 3. Just count by 3s, we never hit it. 3, 6, 9, never hit a 4. So it's not a perfect cube, but it is a perfect square because the exponent is even. Also 25 is a perfect square. So we find A and B. A is the square root of x to the fourth power. Find the square root, divide the exponent by 2. 4 divided by 2 is 2, so that gives us x squared for A. B is the square root of 25, and that's 5. Put it in the difference of squares formula. We get x squared plus 5 and x squared minus 5. Now we should always check these to see if we have something here that's factorable. Well, this could be difference of squares here because we have a perfect square here, but 5 is not a perfect square, so we can't factor it, so there's your final answer. Number 9. So we have x's in all of these. So we're going to be able to factor out an x. And we can also factor out a 6. 6 is the greatest common factor of 18, 48, and 32. So we'll factor out 6x. Oh, no, that is not right. 6 is not divided into 32. What am I thinking? Biggest number that divides into all those is just 2x. So factor out a 2x. Okay, so 18 divided by 2 is 9. X to the third divided by x is x squared. 48 divided by 2 is 24. And then x remaining plus 16. All right, now let's take a look at this trinomial inside the parentheses. It looks like we have a bunch of perfect squares. 9 is a perfect square, x squared is a perfect square, 16 is a perfect square. So let's try perfect square trinomial. Take the square root of the first term to get 3x. Square root of the last term to get 4. 2ab is 2 times 3x times 4, which equals 24x. That matches the middle term, so we have a perfect square trinomial. So that means I'm just going to take 3x and 4, square it according to the perfect square trinomial formula, and we are done. Number 10. So we have a binomial, and its addition, it's the only binomial that we can factor that has addition in between, is sum of cubes. Are these perfect cubes? Yeah, 27 is a perfect cube. Anything to the third power is a perfect cube. Third power, 64 is a perfect cube. So we can do sum of cubes. All right, now third root of 27x to the third, that is 3x. Third root of 64, y to the third power is 4y. All right, so 3x and 4y will be our a and b values. Now we'll take those and plug them into the sum of cubes formula. All right, we have addition, so the first binomial will be addition, so that's 3x plus 4y. Now we'll do the trinomial. A squared will be 3x squared, so that's 9x squared. Now, for the middle term, switch from addition to subtraction and multiply a times b. 3 times 4 is 12. Keep both variables, 12xy. And finally, we're going to square b on the end, and that is 16y squared. So we've got a trinomial here. Looks like we have some perfect squares here. X squared is a perfect square because the exponent is even. Same here. 4 is a perfect square. So it looks like we may have a perfect square trinomial. Let's try it out. A is the square root of x squared, which is x. B is the square root of 4y squared, which is 2y. And that makes 2ab equal to 2 times x times 2y, which equals 4xy. And that matches the middle term. So it is a perfect square trinomial. So now we've got subtractions. That means our binomial will be subtraction. We'll do a, which is x, minus 2y, and squared. Number 12, got another one with some binomials here. So first thing I'm going to do is factor out the matching binomial. That's going to come out front. Everything is not removed remains. So we'll take that out. What remains is 4x plus 1. And then we'll subtract. This thing's already gone, so it's out front. We're going to subtract 3x minus 11 in parentheses. Always put them in parentheses because we're subtracting that whole binomial. Now I'll simplify here. We'll do 4x plus 1 minus 3x minus negative 11. That's the same as adding positive 11, so plus 11 on the end there. We'll simplify here. 4x minus 3x is x. 1 and 11 is 12. So final answer, x plus 8 times x plus 12. So we've got a 4-term polynomial. That means factoring by grouping. Doing 2 at a time. Here we can factor out 4x to get x plus 2. And now we need to match the x plus 2, so we can factor out 36. Or negative 36. Now in this case, we could have factored out 4 from that first expression. That's another way of doing it. We'll have to factor the 4 out later now, since we didn't do it before. Okay, so that completes the factoring by grouping. Now we've got a GCF here, we can factor out the 4. Oops, that's x squared. Should have been an x squared there. That's my mistake. 4x squared we're factoring out. Okay, so that gives us x squared minus 9, x plus 2. All right, now we need to examine these to make sure none of these are factorable. As it turns out here, we've got a perfect square subtracting another perfect square. So you have difference of squares. A and B will be x and 3 here, so that gives us 4 times x plus 3 times x minus 3 times x plus 2. Number 14. So this one, it looks like we have sum of cubes if you look at the variables. But the numbers aren't perfect cubes. So that tells us we should factor something out first. And once we do that, we'll probably get perfect cubes here. So if we factor out a 4, what remains is 27 and 125, both of which are perfect cubes. So that means we do have sum of cubes now inside the parentheses. Now we can take the third root of both terms. So third root of 27 is 3. Third root of x to the 6 is x squared. Remember, divide the exponent by the index. 6 divided by 3 is 2. Now for b, we take the third root of 125 y to the 9th. Third root of 125 is 5. Third root of y to the 9th is y to the 3rd. 9 divided by 3. All right, now we've got our a and b values. Now we can plug them into the formula. We're doing sum of cubes, so our first binomial will be addition. That gives us 3x squared plus 5y to the 3rd. And now for the second set of parentheses, we'll start off with a squared. So that's 3x squared squared. Square root of 3 to get 9. X squared squared, multiply the exponents to get x to the 4th. So there's 9x to the 4th power. Now we're going from addition, switch over to subtraction. Now we'll multiply a times b. 3 times 5 is 15. And then keep both x squared and y to the 3rd. And then we'll square this last one. 5y to the 3rd, square that. Five squared is 25. Y to the 3rd squared, multiply the exponents to get y to the 6th. So that's 25 y to the 6th power on the end. Next up, number 15. Four terms, so we do factor by grouping. We want to factor out the smallest exponent on the x, so that's x to the 4th. So we do x to the 4th times x to the 5th divided by x to the 4th is x. X to the 4th cancels, so we get x plus 3. Right now it looks like we have matching terms with different signs. That means we need to turn it negative. I'll turn everything inside the parentheses positive. And then the unwritten coefficient here is a 1. Now we can complete the grouping by doing x plus 3 times x to the 4th minus 1. But we still have more to do here, because now we have difference of squares here. And a is going to be x squared, and b is 1. Right, square root of x to the 4th, divide 4 by 2 to get 2, so x squared. Now we use the difference of squares formula, so that is x plus 3 times x squared plus 1 times x squared minus 1. Now that's not factorable. That's not factorable because those are not perfect cubes, but here we have another difference of squares. So we got to take the square root of x squared to get x, square root of 1 to get 1. So one more difference of squares and we get x plus 3 times x squared plus 1 times x plus 1, x minus 1. So the clue of which type we've got here in number 16 is the variables. We have a perfect cube here and a perfect cube here. The only problem is that 81 and 3 are not perfect cubes. So just like we saw in a prior example, we need to factor out a number first, and that will reveal difference of cubes. So we can factor out a 3 to get 27, x to the third minus y to the third. And now we've got difference of cubes inside the parentheses. So a will be the third root of 27, x to the third. So that's 3x. And b will be the cube root of y to the third, which is y. So our first binomial would be subtraction because it's subtraction up here. That will match the first one. And then we'll do a squared. 3x squared is 9x squared. And in the middle, switch from subtraction to addition. 3x times y is 3xy. And on the end, b squared, which is y squared. On to number 17. So you got 1 minus, no, I don't need that. 1 minus x to the 16th power. Now this could be difference of cubes, but 16 is not a multiple of 3, so that cannot be a perfect cube. But it is even, so it is a perfect square. So we have difference of squares. So we want to do the square root of x to the 16th power. Take 16, divide it by 2, because it's a square root, and we get x to the 8th power. So that gives us 1 plus x to the 8th times 1 minus x to the 8th. Well, now we need to do it again, because this is also difference of squares. Divide that by 2 to get x to the 4th power. We're going to have 1 and x to the 4th power is a and b. So that'll be 1 plus x to the 4th times 1 minus x to the 4th. Can't factor either of those, but now we have another difference of squares here. So 1 plus x to the 8th times 1 plus x to the 4th. And divide that by 2, we're going to get x squared now. So 1 plus x squared, 1 minus x squared. Now we got one more difference of squares there. So this turns into 1 plus x to the 8th, 1 plus x to the 4th, 1 plus x squared, and we'll split this up into 1 plus x times 1 minus x. And there is that one. Number 18. All right, this one kind of looks like a quadratic, but we've got these funky binomials in there. So let's get rid of those through substitution. So I'm just going to define some variable, it doesn't matter which one, a equals 5x plus 2y. Just make sure it's a different letter so it doesn't get confusing. Now if we substitute then, every time I see 5x plus 2y, I'm going to plug in a. So this becomes a squared minus 6a plus 9. Well, now we've got a perfect square trinomial. We got perfect square, and that's going to factor into a minus 3 squared. Just using the perfect square trinomial formula. Now we get to plug back in. So I'm going to plug back in 5x plus 2y in for a. We only have one thing to substitute for and nothing to simplify, so that'll be our final answer. 5x plus 2y minus 3 squared. All right, so we got a big mess here. Let's try to simplify this thing down. If you look at the numbers, no common factors in those numbers. But what we do have that's common to all these is m squared. We have an m squared in each one of these. So let's take that out. All right, so now we can do factoring by grouping since we have a 4-term polynomial inside here. And I don't think it's going to matter which way. Could flip these, but I think it'll factor just fine this way. So if we factor these two, we can factor out 3n. And that gives us n squared plus 5. And over here, if I want to match n squared plus 5, I can factor out a negative 2. So minus 2, and we get n squared plus 5. Completing the factoring by grouping, n squared stays on the outside, n squared plus 5 comes out, and what remains is 3n minus 2. So impossible to do until we get rid of that greatest common factor first. Then it's straightforward factoring by grouping. Number 20. All right, let's see if there's something we can factor out here. Looks like we have all even numbers, so we can factor out a 2, and all terms have at least one x. So let's factor out 2x. All right, 2x to the third divided by 2x is x squared. We get a 4 there. X squared y. And 4y. Now, as it is, it does not look like. Oh no, we can't do factoring by grouping as it is. We could rearrange it, but it looks like this will work just the way it is. So here, we're going to factor, we can't factor anything out here, so we'll just bring a 1 out just for clarity. X squared plus 4 plus, and over here, if we want to get x squared plus 4, we need to factor out the y. So we get y, x squared plus 4. All right, now completing the factoring by grouping, bring out this x squared plus 4, and we get 1 plus y for the other one. Last one, number 21. All right, this one looks a little different until we realize that we've got something to the third power here and the third power here, making those perfect cubes. We have subtraction in the middle, so difference of cubes. Now, the nice thing about having things to the third power, when we take the third root, we just get what's inside the parentheses. So A is just x plus 2y, and B is x minus 3y. Now we can plug those into the difference of cubes formula. So first thing is going to be A minus B. So it'd be A, x plus 2y, minus, in parentheses, x minus 3y. Now the second part, now we need A squared. So this will be x plus 2y squared plus A times B. So these two multiplied. Plus b squared on the end. So that is x minus 3y squared. Now to simplify. So here we got x minus x, and then 2y minus negative 3y. This thing simplifies down to 5y. All right, now for this mess inside here, we got this thing squared, so that's going to be x squared plus 4xy plus 4y squared. Now FOIL here, x squared minus 3xy plus 2xy minus 6y squared plus, I'll square this thing, x squared minus 6xy plus 9y squared. Now I can simplify inside these parentheses. Boy. All right, these end up being extraneous. Don't really need those parentheses. See how many x squared terms we have. We got x squared plus x squared plus x squared. All right, now let's do the xy's. We got 4xy minus 3xy, that gets us down to 1xy, plus 2 more, back up to 3. 3 minus 6 is negative 3, so negative 3xy. Now we'll do the y-squareds. Got 4 of them here. Minus 6 is -2. Plus 9 is 7. And there is your fully factored form. Let's see here. See if I made any mistakes. -1. Oh, that's -5. And I think that's it. All right. So that one was a bit of a nightmare. You'd never see one like that on exam, but it's good practice. All right, everybody, that's it. Have a great day.